Let us now consider functions that involve the radical sign. So suppose we have a function f whose limit as x approaches a exists, and we want to take the limit of the nth root of the function f. Then we have this result. So the limit of the nth root of f of x as x tends to a is the same as the nth root of the limit of f of x as x tends to a, if this limit here exists, provided that when n is an even index, then the limit inside the radical sign should be positive. So for example, let us consider the limit of the square root of 3x minus 1 as x tends to 3. The index here is 2, which is even. So the limit of the radicand should be positive for us to be able to apply this result. Now, 3x minus 1 is polynomial. So all we need to do is to plug in 3 to x to get the limit of 3x minus 1. And so we have 3 times 3 minus 1, which is 8. This is positive. So we can apply the above theorem. So the limit of the square root of 3x minus 1 as x tends to 3 is equal to the square root of the limit of 3x minus 1 as x tends to 3, which is equal to the square root of 8, and simplifying, we get 2 square root of 2. For the next example, we want to consider a cube root. So in this case, taking the limit of the cube root, we don't need to check whether the limit of the radicand inside the radical sign is positive or not. However, the radicand in this case is a rational function, so we need to check whether this radicand here has a limit. So the numerator and the denominator being polynomials, we can substitute -1 to x, provided that the rational function is defined at -1. And that is the case in this example. When we plug in the -1 to x, we will get -1 plus 4 divided by -1 minus 2. And the numerator is equal to 3, while the denominator is equal to -3. So dividing, we get -1, and so we get the cube root of -1, which is equal to -1. Now for the last example, we want to consider the fourth root of 3 minus 2x. And here we want to get the limit of the expression as x tends to 7/2. Now note that when you plug in 7/2 to x, you will get 3 minus 2 times 7/2, or 3 minus 7, which is -4. So the resulting expression is the fourth root of -4, which is not a real number. So here, take note that the limit of 3 minus 2x as x tends to 7/2 exists. However, it is negative. Now the index being 4, it is even. And so we have the condition that the limit of f of x should be greater than 0. And so in this particular example, the limit does not exist. Now let us look at a slightly more complicated expression that involves the radical sign. So here we want to get the limit of the cube of the quotient 2x squared minus the square root of 5x plus 1 divided by x cubed minus x plus 4. Okay, so to solve this limit, we can apply some of the properties that we've learned previously. So for example, we can put the limit sign inside the parentheses, and so we will have the cube of the limit. Moreover, we can express this limit of the quotient as a quotient of limits and distribute the limit to the difference in the numerator. And so we will have the limit of 2x squared minus the square root of the limit of 5x plus 1 as x tends to 3 divided by the limit of the polynomial denominator x cubed minus x plus 4. Now, the limit of 2x squared as x tends to 3 is simply 2 times 9 or 18, and the square root of the limit of 5x plus 1 as x tends to 3 is the same as the square root of 16, which is 4. And so the numerator is the same as 18 minus 4, while the denominator is 3 cubed minus 3 plus 4, or 28. So the expression inside the parentheses is 14 over 28, or 1/2. And raising that to the third power, we get 1 over 8. Now note that in this computation, we've used several results from the two theorems and the theorem that we have discussed just previously. Now it's up to you to justify the steps that we have committed here and check that, for example, in evaluating the limit of the numerator here, both the limit of 2x squared and the limit of the square root of 5x plus 1 exist. So do the same for every line in this series of equations. Now, after verifying that all the steps in this computation are valid, we can conclude that the limit of this cubic expression as x tends to 3 is equal to 1 over 8.